Let us switch over to problem number 26. Let me read out the problem once. The electron moves with a speed of √3 times velocity of light by 2. Then its mass becomes dash times its rest mass. Let me repeat. An electron moves with a speed of √3 by 2 times velocity of light. Then its mass becomes dash times its rest mass. The options are given this way. The first option is given 2, second option is 3, third option is 3 by 2, and fourth option is 4. What is the correct option out of the 4? If you want to look at, you should recollect once again from theory of relativity what has been given by Einstein, how the mass of a particle that varies with respect to its velocity. In fact, we people have discussed the same formula in this form. M is equal to m0 by root of 1 minus v square by c square. This is the variation of mass what has been predicted by Einstein by taking theory of relativity. In fact, according to this particular theory, mass is a variable, length of a body is a variable, and even time also is a variable depending on the velocity like. So if you look at in this particular case, m0 refers to the rest mass of the body or the particle what has been considered there, and v is its velocity and c is velocity of light. So one should understand here, velocity is now given as √3 times c by 2. That is what has been provided in the problem for us. So what can we write from this one? Directly v square by c square, you can write that one as 3 by 4. Suppose if you just substitute this value over here, m now becomes m0 by root of 1 minus 3 by 4, which now becomes 2m0. You can certainly understand 1 minus 3 by 4 now becomes 1/4. Root under 1 by 4 is 1 by 2, and that of course comes up 2m0 it will be. So the value of mass of that particular particle is going to be doubled. Doubled of what? Its initial mass or the rest mass. So we can directly understand the mass of this particle, which is electron that has been mentioned in the problem, is now twice its rest mass. So automatically out of the 4 options mentioned in the problem, first option is going to be correct now. So we can say the answer for this particular problem is simply A now. So that is the concept what we have to get. But all of you should understand this particular formula is going to be very useful for us in atomic physics and even in nuclear physics part of our chapters. What for means, at times when velocity of the particle is more, then automatically its mass is going to be a variable. According to that only, we people used to calculate either its momentum or its kinetic energy, or for that matter based on those values de Broglie wavelength and other things like. So this is actually the problem number 26 what we people are having in this order. Let us work out the next number, that is problem number 27. A proton, when accelerated through a potential difference of v, has a wavelength lambda associated with it. An alpha particle, in order to have the same wavelength, lambda must be accelerated, same wavelength lambda must be accelerated through a potential difference of how much? Let me once again repeat the question. A proton, when accelerated through a potential difference of V, has a wavelength lambda associated with it. An alpha particle, in order to have the same wavelength lambda, must be accelerated through a potential difference of how much? Options are given this way. The first option is V by 8, second option is V by 4, third option is given as V, and fourth option is given as 2V. One thing you should understand here, proton is a particle, alpha is a particle. Particle's wavelength, that only you can calculate in terms of de Broglie wavelength. That in the sense you should understand de Broglie's concept when we consider dual nature he has predicted. That means a particle can behave like a wave. Same is the case the other way also. That in the sense you can understand a particle like proton, like alpha particle in this particular problem, can have wave nature with certain wavelength lambda also. And we all know what is the formula for de Broglie wavelength lambda. If you recollect that formula, lambda is equal to h by p. That is the formula what we people have to take up. H being Planck's constant, p being the linear momentum of that particle what has been considered there. And of course we can rewrite the same formula this way, h by root of 2m into kinetic energy we can write. That is actually the conversion of momentum into kinetic energy of the particle. Momentum square by twice mass is equal to kinetic energy. Based on that, we have just converted P into kinetic energy using this equation, root of 2m into Ke. But in the case of a particle, we can write the same this way, 2m into Q into V. You people can understand V being potential difference that is applied across. Q is the charge. Then when a charge Q is accelerated through some potential difference V, then what is going to be the energy gained by the particle we all know. That is nothing other than QV. So I can directly write that formula over here. Then what you can predict the relation between lambda, charge and mass. Look at carefully here, same potential difference he is not asking. He is asking you the potential difference that is required. But what is constant here? Wavelength should be constant for both proton and alpha particle. That is one area you have to first of all understand. And secondly, the value of 2 is a constant, h is a constant. Then what are the three variables you are finding in that problem? Look at mass being a variable, charge being a variable, potential difference also is supposed to be varied for both the particles to have the same wavelength lambda. That is the concept. So what can we write now? This implies V is inversely proportional to charge into mass of the particle. This is the relation we can directly arrive at by looking to this actual equation. So what can we write now in this case? V of proton and by V of alpha particle, the potential difference applied on proton and potential difference applied on the alpha particle, that now should be equal to charge on alpha particle into mass of alpha particle by charge on proton into mass of proton. This is actually the equation. But all of us we know pretty well, charge on alpha particle is 2 units. Mass of alpha particle is 4 units divided by charge on proton will be taken as 1 unit and mass also will be taken as 1 unit. So what can we directly write in this case? This now becomes 8 as such. The outcome here is 8. Now can't you just guess what should be the potential difference that should be applied on alpha particle for it also to have the same wavelength? Can't you calculate that? V alpha now becomes V of proton by 8. So this already has been given in the problem as V. Therefore, how much potential difference that is to be applied on the alpha particle for it also to have the same wavelength lambda? That is the question what he is asking. So how much it should be now? V by 8. That is the correct value of potential difference that is to be applied on alpha particle for it to have the same wavelength lambda like the proton. That is the case what has been taken up. So the same option, if you look at, it is tallied with the very first option given there. The outcome here is tallying with the first option. Therefore, the answer for this problem number 27 is going to be V by 8, which is the first option given over there out of the 4. That is the case. Switch over to next number 28 now. If kinetic energy of a free electron doubles, its de Broglie wavelength changes by a factor of. Kinetic energy of electron is doubled. Its de Broglie wavelength changes by a factor of. First option is 1 by root 2 times. Second option is simply root 2 times. Third option is 1 by 2 times, and fourth option is 2 times. The same question has been given earlier in IIT-JEE in the year 2005. So this type of a question is common, like in many a number of entrance examinations earlier also, similar model has appeared. Therefore, one should concentrate a little carefully on this type of a model. Kinetic energy of free electron is doubled. It's a de Broglie wavelength. So one should first of all understand de Broglie wavelength lambda now can be taken up as h by p, as I have already written the same formula in the previous problem also, h by p. Now the question is, if kinetic energy is doubled, he is asking. That means all the rest of the quantities are constant only. It is understood. And that too, he is not comparing two different particles over here in this problem like in the previous one. Here only one particle he is taking up. That particle is electron. Therefore, its charge remains constant, its mass remains constant. Every other feature of that electron will be the same excepting the kinetic energy, which is doubled according to the given problem. So we can directly write now h by root of 2m into kinetic energy directly like this. So what we can predict from this equation, please? Lambda is inversely proportional to square root of kinetic energy. This is the outcome of this equation what can be taken up. So what we can write now from this one is lambda 1 by lambda 2 is equal to root under kinetic energy 2 by kinetic energy 1. That is of course final kinetic energy. This is initial kinetic energy, like that also we can write. Now you can rewrite the same this way. Kinetic energy is doubled, he said. Therefore, twice Ke1 by Ke1 we can write. This now becomes simply root 2. The moment this ratio is root 2, what is his question? Its de Broglie wavelength changes by what factor? That is the concept. So we can directly understand from this, lambda 2 now is going to be 1 by root 2 times lambda 1. That means what is the factor? Here we have to identify. It is now 1 by root 2 times the original value. So what is the factor here to be identified? It is 1 by root 2. So which option is tallied with that? I have already read the options earlier. First option is 1 by root 2. Second option is root 2. Third option is 1 by 2. And fourth option is 2. So automatically the very first option that tallies with this result what has been calculated here. So correct answer for this problem is the first option for this problem number 28. Let us move to the next number 29. If lambda naught is de Broglie wavelength for a proton accelerated through a potential difference of 100 volt, then the de Broglie wavelength for an alpha particle accelerated through the same potential difference is. Options are given this way: lambda naught by 2 the first option, lambda naught by 2 root 2 the second option, lambda naught by root 2 the third option, and 2 root 2 times lambda naught the fourth option. Same potential difference he is giving. So what we should once again understand, lambda is equal to h by p. The same can be rewritten as h by under root 2m into qv. Now look at 2 constant, v constant, h constant. Lambda is a variable depending on mass of the particle and charge on the particle. So what can we write now? Lambda proton by lambda alpha particle is equal to under root mass of alpha particle into charge on alpha particle by mass of proton into charge on proton. So what can we write now in this case, please? Mass of alpha particle is 4 units, charge is going to be 2 units, divided by mass is 1 unit for a proton, and even charge also is going to be 1 unit for the same proton. So it comes to be 2 root 2. So what is the question he is asking? What is the wavelength, the de Broglie wavelength of alpha particle? Therefore lambda alpha now becomes lambda of proton by 2 root 2. This actually is the relation. So lambda of proton by 2 root 2, what is lambda of proton given in the problem? It is given as lambda naught. Therefore lambda naught by 2 root 2 must now be our answer. So which option that is true over here? The second option, if you look at lambda naught by 2 root 2 he has given. Therefore the correct answer for this particular question is going to be B for this problem number 29 what we have. The next number is problem number 30 for us. It's a wonderful model which has been asked in 2004 in the screening examination of IIT. IIT screening paper 2004, they have asked this question. So model is an excellent one. The energy of a photon is equal to the kinetic energy of a proton. He is comparing two different elements here. One is a proton which is having particle nature. One is a photon which is having wavelength, that is wave nature like. So if you look at that one, the energy of a photon is equal to the kinetic energy of a proton. The energy of the photon is E. He gave that value. If lambda 1 be the de Broglie wavelength of the proton and lambda 2 be the wavelength of the photon, then lambda 1 by lambda 2 is proportional to what? He is not asking you the total equation or value for that. It is directly proportional to which quantity? The 2 in terms of energy. What is the relation? First option he gave as e power 0. Anything to the power 0 is 1. That means there is no such relation. It is understood according to the first option given there. And second option he says e to the power half. So you can understand it is root under e. Third option he said e power minus 1. and fourth option is e to the power minus 2. What is the correct option? First understand what is the relation he has mentioned. Energy of a photon is equal to energy of a proton. Which energy? Kinetic energy of the proton. That's what has been mentioned first. And what else he has given? Energy of the photon is given E. Energy of photon is given E means kinetic energy of proton also will be E only. There is no doubt absolutely in that. Next one. Lambda 1 be the de Broglie wavelength of the proton. So let us write first of all for the proton what has been given to us. Lambda 1 is equal to h by root of 2m into kinetic energy. I am talking of proton, please. Observe the wording. For the proton, lambda is h by under root 2m into ke. I now rewrite the same as h by under root 2m into E, because he has already mentioned the kinetic energy of proton is equal to E. So this is my first equation as far as proton, which is the particle, that is concerned. Now come to the other one, that is a photon, which is having wave nature. So what next he is talking? Lambda 2 be the wavelength of the photon. Wavelength of photon. So you can understand here for the photon, you can write now lambda 2 is equal to, in fact you know very well, energy is equal to h nu. There is a formula for photon. Photon energy is h nu according to quantum theory. We know that. That can be written as hc by lambda. So what I can write lambda now? Lambda is hc by energy. That is my second equation. So this is the wavelength corresponding to that photon, and this is the wavelength corresponding to that particle natured proton. Now what is the ratio he is asking? You look at first. Lambda 1 by lambda 2 we want. So write the same ratio. Lambda 1 by lambda 2. This now can be written as h by under root 2me into, reciprocate this one, E by hc. H okay gets cancelled, fine. This is m to the power half, e to the power half, 2 to the power half. This now if I take, right, 1 by c root 2m. You keep these things as it is because we don't need them at all in our problem. Only the relation with energy he is asking. So this is E, this is e power half. If it comes to the numerator, automatically you will be getting this one again as e power half. So if I just take this one as a constant, then can't I just write lambda 1 by lambda 2 is directly proportional to e to the power half now? So that is what he is asking you. It is directly proportional to what is the question. He is not asking you the complete equation. Complete equation means you should have mentioned this one as the answer. But he is not asking you that way. He is simply asking you how the energy is related to this lambda 1 by lambda 2. In what manner lambda 1 by lambda 2 is proportional to that energy. That is what he is asking. Therefore, it should be now proportional to e power half. E power half, according to the 4 options given to us, is the second option for us. Therefore, the second option is the right option for this ratio of wavelengths. So lambda 1 by lambda 2 is proportional to e to the power half, that is square root of e as such. That is problem number 30 for us. Switch over to the next number, problem 31. If the momentum of an electron is changed by Pm, then the de Broglie wavelength associated with it changes by 0.5%. The initial momentum of the electron will be how much? I once again repeat, if the momentum of an electron is changed by, understand that point, not changed to, changed by Pm, then the de Broglie wavelength associated with it changes by 0.5%. The initial momentum of electron will be, first option, Pm by 200. Second option, Pm by 100. Third option, 200 times Pm. And fourth option is 100 times Pm. So 4 different options have been mentioned. We now have to decide what is the correct option for this problem number 31. If you look at once again, lambda is equal to h by p. You can directly understand lambda is inversely proportional to p. No doubt absolutely in that. That means if lambda increases, p decreases and vice versa. Now let me write the same this way, delta lambda by lambda is now going to be delta p by p with a negative sign I can write. What for you can understand is p power minus 1, there is nothing special there. Minus 1 into delta p by p. So that is a negative of delta p by p. That's what actually is given. So what we should understand is de Broglie wavelength is changed by 0.5%. So you can directly write this value now becoming 0.5%. That's 0.5 by 100. That now is going to be delta p, that is given as Pm by p. In fact, that negative sign, what it indicates? When one increases, the other one decreases, that's all. The relation between these two is inversely relation. That is the only thing what we can identify from that, nothing more. So what we can understand here, this now goes exactly 200 times. So what is now left over? P must be 200 times Pm. So what is the relation between this value lambda and this value p? First you estimate from this equation. Then you write delta lambda by lambda is negative of delta p by p. That negative sign gives you when one increases, the other one decreases. That means the relation between them is inversely relation. That is a point you have to understand. And therefrom I have got the initial momentum of that electron, what he is talking about is 200 times the change that has been made in this problem. So 200 times Pm. So which is the correct option for us? The correct option is exactly the third one now. So answer now becomes C for this particular problem number 31. One of the excellent models again. This lambda and p relation in terms of the variation in the values. That of course we used to calculate these models to calculate the general errors or fractional changes. That is what actually we people have used over here. So the correct answer is 200 times Pm, which is the option C according to the 4 options given to us in this problem number 31. Let us switch over to the next number in this order, that is problem 32. If the energy of a particle is reduced to 1/4 its initial value, then the percentage increase in its de Broglie wavelength will be how much? Wavelength is increasing. and energy is decreasing. What is the percentage increase in de Broglie's wavelength? That is a question. 4 options have been mentioned once again. The first option is 41%, second option is 141%, and third option is 100%, and fourth option is 71%. Now you can all understand what is the relation between de Broglie wavelength and the kinetic energy. Energy means kinetic energy, that too of a particle he is talking. Certainly the particle must be in motion, so that energy is referring, what he is referred to is definitely the kinetic energy of the particle. So what we can write now? This lambda is equal to h by root under 2m into Ke. This is the formula known to all of us. So we now can write lambda is inversely proportional to square root of kinetic energy. That is actually the equation what we can come to a conclusion like. That is the relation between lambda and kinetic energy. Now I can rewrite the same equation as lambda 1 by lambda 2 is equal to root under Ke2 by Ke1. What is kinetic energy now? It is reduced to 1/4, not by 1/4. Suppose if it is reduced by 1/4 means remaining kinetic energy becomes 3/4. But here he is giving you very clearly it is reduced to 1/4. So we can write kinetic energy 2 as Ke1 by 4. Into this Ke1 will be as it is in the denominator. So that now becomes half. Then what will be this value lambda 2 now? It is twice lambda 1. Observe the condition carefully now. Initial wavelength was lambda 1. De Broglie wavelength initially was lambda 1. Now it is 2 lambda 1. Then can't you understand? It is being doubled. Doubled means in terms of percentage, how much percentage? 100% rise. So you can even calculate this way also. Delta lambda by lambda into 100 will now be the percentage variation there. What is the delta lambda now to be taken as? Lambda 2 minus lambda 1 by lambda 1 into 100. But all these need not be written. At the standard of JEE level, generally you can understand the moment it is doubled, you can come to a conclusion its increasement is cent%. Otherwise, okay, there is a formula like this. Lambda 2 minus lambda 1 now of course is going to be 2 lambda 1 minus lambda 1 by lambda 1 into 100. So how much it is now going to be? 100%. So that is the one. But this is one methodology. By using the formula you can go for. Otherwise, by looking to this value you can identify the moment lambda 1 is doubled, you can understand this implies 100% rise you are finding in the wavelength of that particular particle. So you can say the increasement in wavelength, de Broglie wavelength is 100%. So what is the correct option there? Option C that has been given as 100% here. So automatically C will be the correct option for this problem number 32. That is the case for us. Switch over to problem number 33 now. The de Broglie wavelength associated with a thermal neutron of mass m at absolute temperature T, if K is Boltzmann constant, is how much? Capital T is given absolute temperature of thermal neutron now. K is given Boltzmann constant now. What is the de Broglie wavelength of that thermal neutron in terms of K and T? It is in fact a small formula like. But you need to know how do you get that. First option is h by under root m kt. Second option is h by under root 2m kt. Third option h by under root 3m kt. And fourth option h by 2 root m kt. So what is the correct option out of the 4? He is asking you to calculate de Broglie wavelength of a thermal neutron. So directly you can write lambda is equal to h by mv. That you can write that one as root of 2m into k. You can all understand well, for a neutron, kinetic energy in terms of the value of k is 3 by 2 kt, k being Boltzmann constant, T being absolute temperature of that particular particle given. So substituting that one over there, lambda will be h by under root 2m into 3 by 2 kt. 2 getting cancelled. What is now left over? H divided by root of 3m kt. That must be the correct formula. So you can even remember this formula also once for all without calculating or deriving then and there itself like. So h by under root 3m kt, when this is the correct option for us, it is exactly the same as the third option given in the problem number 33. Therefore, the correct answer for us is going to be C for this problem number 33. That is what you have to remember. Next number is 34th. Problem 34 is a simple application of that problem number 33 what we have taken up. The de Broglie wavelength of a neutron of at 927 degrees centigrade is lambda. Neutron is at 927 degrees centigrade. That value of its de Broglie wavelength at that temperature is given as lambda. Its de Broglie wavelength at 27 degrees centigrade is how much? One is 927 degrees centigrade, which of course if you add 273 to that one, it becomes 1200 Kelvin. And the other temperature is 27 degrees centigrade, which can be taken as 300 Kelvin. So what are the 4 options given? First option is lambda by 2. Second option is lambda. Third option is 2 lambda. And fourth option is 4 lambda. Now you people all know what is the value of de Broglie wavelength for a neutron like particle. It is h by under root 3m kt. That is actually the formula, k being Boltzmann constant and T being absolute temperature of that neutron. So what can we write from this one now? Lambda is inversely proportional to square root of absolute temperature. So what can we write now from this? Lambda 1 by lambda 2 is equal to under root T2 by T1. T2 you all know that as 300 Kelvin because 27 degrees centigrade has been mentioned. And T1 is now going to be 1200 Kelvin because 927 degrees centigrade is given. So you can cut this one 4 times, so it now becomes half. It is 1 over 4 under root means it is 1 by 2. Then what is the question he is asking? What is its wavelength yet to this 300 Kelvin, that is 27 degrees centigrade. So we just can write lambda 2 is going to be twice lambda 1. But lambda 1 in this problem is already given as lambda. Therefore, this now becomes 2 lambda for us. So correct answer for this one is 2 lambda, which of course is the third option mentioned for us. Therefore, we can write directly the answer for this one is simply see now for us. That is the concept. So de Broglie wavelength of neutron is inversely proportional to square root of absolute temperature. That is the concept what you have to remember for solving this type of a problem that is given as 34th for us. The next number is 35th. A wonderful model question with excellent description for that. The de Broglie wavelength of a bus moving with a speed of v is lambda. Some passengers left the bus at a stoppage. Some people have got down. When the bus moves now with twice its initial speed, its kinetic energy is found to be twice its initial value. Usually what we think of is, when speed is doubled, kinetic energy becomes 4 times. That's what we generally feel. But in this case, since some of the people have got down, some of the passengers have got down, the kinetic energy also is increased 2 times only, according to him. Its de Broglie wavelength now is how much? So velocity is doubled, kinetic energy of the bus also is doubled. That is the thing what he is talking about. Now what is the de Broglie wavelength? First option is given as lambda, second option 2 lambda, third option lambda by 2, and fourth option lambda by 4. So 4 different options have been given. What is the correct option we have to look into? So in true sense, we directly can understand de Broglie wavelength lambda is equal to h by p. P is linear momentum over there of that bus what we are talking about in the problem. But how to just write this momentum in terms of kinetic energy we all know. Now what is that formula over here? Generally P is equal to under root 2m into Ke. But what we have to understand here is, I want velocity to be there in that and kinetic energy also to be there in that. So what is the method we people have to adopt over there? Twice kinetic energy by velocity if I write, you can definitely get momentum. Look at now, momentum can be written twice kinetic energy by velocity. What is this twice kinetic energy? Twice half mv square. 2 getting cancelled, you are left with mv square in the numerator. mv square by v, v getting cancelled, you are left with momentum once again mv. So in place of p, I write this one. So this is the relation you people have to take for this. So this implies lambda is equal to h by twice Ke by velocity v. Now you take initial wavelength de Broglie wavelength lambda, final de Broglie wavelength lambda, first one lambda 1, second one lambda 2. H being constant, 2 being constant, what can I write now? It can be taken as Ke2 by V2 divided by Ke1 by V1. Lambda is inversely proportional to kinetic energy by velocity. That is the concept what I have taken up. So we now can rewrite the same this way: kinetic energy final by kinetic energy initial into initial velocity by final velocity. What are the values given in the problem? Now you look at them and substitute them here. What is final kinetic energy? He said it is twice the initial kinetic energy. Initial kinetic energy Ke1 I am writing, then automatically Ke2 becomes twice the initial kinetic energy, twice Ke1 into what next we have? velocity 1 is as usual. Second velocity is twice the initial velocity. So 2 times v1 you can directly write. Now everything gets cancelled, kinetic energy gets cancelled, velocity gets cancelled, 2 gets cancelled, and what is now left over? You are getting it as 1. So in what way lambda 1 and lambda 2 are now related, you can identify. So you can straight away say that lambda 1 is equal to lambda 2. But lambda 1 in the problem is already given as lambda. Therefore, even lambda 2 also is equal to lambda. So which is the correct option over there? You look at first option only, he has given it as lambda. So you can directly say the answer for this particular problem is simply A for us. That is the concept. So if you look at that problem number 35, only point you should understand is how to write momentum in terms of kinetic energy and velocity of the body. So it is twice Ke by V. You better write like that. Then automatically that gives you the momentum value, and according to that ratio you estimate what is the value that is required. So it is as well equivalent to lambda. That means lambda 1 and lambda 2 in this particular case are equal. That is the concept we have to understand.